All right, the last piece with this lesson that we have to go over is talking about one-sided limits. So the limit as x approaches c from the right is equal to L, and the limit as x approaches c from the left is equal to L. If they both equal the same thing, then the limit as x approaches c in general, now keep in mind you have a plus sign over here for right, and you have a minus sign over here for left. If you don't see that direction, then you're approaching from both directions. And given that both the left and the right equal the same thing, you can assume that approaching C in general will also be the same thing. If the left side and the right side do not have the same limit though, then this would be an instance where the limit does not exist because you're approaching two different y values, which is what we talked about in section 1.3. So again, if the left equals the right, you're good. The limit exists. If the left does not equal the right, if you don't have a specific direction on it, then you would say the limit does not exist. All right, so the last thing we want to talk about is something called the definition of continuity on a closed interval. So a function f is continuous on the closed interval AB if it's continuous on the open interval AB, so same interval, just now open, and the limit approaching A from the right equals f of A, and the limit as B approaches from the left approaches f of B. So that just means when you sub it in, it equals the same value that the limit equals. And if they're both equal to each other, then it is going to be continuous. So again, this is very wordy. There's a lot of stuff going on there, so let me just show you what we mean by that. So if we were to take this function right here and we were to sketch this, okay, I'm going to take the value that's underneath the square root sign. Square roots can never be negative, so I'm going to set it to be greater than or equal to 0. What I'm going to do is make the x squared positive, so I'm going to divide everything by a -1, which means when I divide everything by a -1, it's going to flip everything on the left. The sign is also going to flip, but that just now allows me to be able to set up my difference of squares. This should be minus, sorry. All right, so when I sketch this, I'm going from -1 to +1, and it's a half of a circle. Okay, this is the equation for a circle in terms of conic sections. All right, so if we now look, according to what this says, it says the limit as x approaches -1 from the right of our function square root of 1 minus x squared. If we subbed -1 in, because you can just sub it in. If the plus, don't freak out with the plus sign because you might be able to still use direct substitution. So if you sub in -1, you get -1 squared, which is 1. 1 minus 1 is 0, and the square root of 0 is still going to be 0. Okay? That, if we check that with f of -1, well, here's my function from the beginning. If I sub in the -1 to that function, I get 0. So those two equal each other. So therefore, we're continuous from the right. Continuous from the right side. Again, we're coming from the right side, so you're approaching -1. It's sort of the opposite of what you think. And now if we go the other way, the limit as x approaches +1 from the left, same thing. We're going to sub 1 in, we get 0. Now if we check f of 1, we're going to sub that into the function, we also get 0. Which means this is continuous from the left. So if you are continuous from the right and you are continuous from the left, therefore f of x is continuous on the closed interval from -1 to +1. Okay, so that can be a little tricky. It's definitely very wordy, but there's a lot to check. It's sort of, think of it, when it says to discuss the continuity, there's a lot of, think of it like a proof from geometry a little bit, but it's just you're not writing in a